Okay, guys, so I already started this problem and then I got interrupted, but I think I could just pick it up from here. So I'm going to do two examples of the integral of an absolute value function. All right. So we're doing this integral here. And first I'm going to take what is inside of it. And I'm just going to make this observation. This is equal to plus or minus the binomial that's inside of it. Okay, so, and then I'm going to do a number line. Whenever this is 0 or wherever it's 0, I'll divide the number line up with it. And then I'm picking testing points, 0 and 5. So if I plug 0 in up here, let's see what happens. So I plug 0 in on this side, and I get that the absolute value of -4, okay, this is equal to, and then I'll plug it over on this side, is this equal to the positive or negative version of what I get in here? So if I plug 0 into the parentheses, I get a -4 in the parentheses, so I would need the negative outside of it. Okay. All right, take your time here, guys, but absolute value, so like pause the video if you need to. So the absolute value of -4 is +4, and then I want a positive outcome on the right, so I would need like a double negative. Okay, so guys, what that means is that on this interval here, to the left of 4, the absolute value of x minus 4 is equal to negative x minus 4. All right, that's what's going to get you the positive outcomes on that interval. All right, absolute value always has positive outcomes. All right, now let's do the 5 and see if it changes. The reason you have to test, guys, is because you don't really know if it changes necessarily. Or just don't take that as a given. So 5 goes in up here, and if I plug 5 in, then I'm getting a +1, absolute value of +1. This is equal to, in the parentheses, I'm getting a +1. And I don't need a negative out front, right? It's already positive. So I'm getting 1 equals 1. Okay, so basically, you don't have to write the plus, it's invisible, but that's positive. So on this interval, to the right of 4, the absolute value of x minus 4 is equal to x minus 4. All right, positive outcomes either way on that interval. Okay, so basically, guys, you did not really need to show all of this if you could do it in your head. That's hard for me. But so now, 4, this number 4 is between -3 and 8. Okay, so -3, let's say it's like over there, and 8 is like somewhere here. So I'm going to have to use two integrals, one from -3 to 4, and then the other from 4 to 8. And that's going to allow me to drop the absolute value bars. So from -3 to 8, parentheses dx plus, sorry, to 4, plus from 4 to 8. Alrighty, now on this interval, from my number line, I've already figured out that the absolute value of x minus 4 is equal to that negative. So I'll distribute the negative also. So -x plus 4 there. And then on this interval, we could just drop the bars. Okay, now I am ready for the fundamental theorem of calculus. Okay, so I'm going to open up some brackets under the integrals. And what goes in the brackets is the antiderivative of what is in here. Okay, so just take note of the exponents. That's x to the first. Alrighty. So for antiderivatives, so -x to the second, but then you divide by 2. So I'm adding 1 to the exponent and dividing by it. Plus, if you've got a constant, guys, its antiderivative is you just put an x next to it. Okay, So there's the antiderivative for that part. The antiderivative over here, it's going to be the same except the signs are different. So this time it's going to be x to the second divided by 2 minus 4x. Okay. Alrighty. And then you're going to plug in the top. That's going to give you the final value minus, you'll plug in the bottom. That will give you the initial value. So it's final value minus initial value now. All right, so I plug in the 4, and I'm getting negative 16 over 2 plus 16 minus, I'm plugging in the negative 3 now. And guys, this negative is outside of the parentheses, okay? So I square negative 3, which gives me positive 9, but that negative is outside. So that's negative 9 halves minus 12. Okay, so that's for this part. All right, so this plus sign is right there. Okay, now I'm plugging in 8 for this one, final value minus initial value. So I'm plugging in 8 to get the final value. So that's 64 over 2 minus 32 minus, you need parentheses after the minus if there's more than one term. So I'm plugging in the 4 now, 16 over 2 minus 16. Okay. So this is negative 8 plus 16 plus 9 halves plus 12 plus 32 minus 32, that's nice, minus 8 plus 16. All right, so those are canceling, that's great. Okay, so I've got here, that's 8 plus 9 halves plus 12. Those together is another plus 8. All right, so I got 16 plus 12 plus, I'll just say 4.5. 20, 32.5? 32.5. Okay. All right, guys, I think I did it right. Plus that is 20.5, 32.5. All right, so that's that first one. I don't have a calculator in front of me, otherwise I would check with Math 9. Okay, so now we've got to do this one. So same idea. So the interval we're dealing with is pi over 2 to 2 pi. So I'll keep that in mind. And I'll go off to the side here. Sine of x equals plus or the absolute value of sine of x equals plus or minus sine of x. Sometimes it's plus, sometimes it's minus. It depends what will give you a positive outcome. That's what you want for absolute value, is a positive outcome. So first I'll figure out where sine is 0. Okay, so sine of x equals 0. You need a unit circle. Okay, sine is 0 at 0, but then also at pi. Okay, at 0 and pi within one rotation. X equals 0, x equals pi. And with the unit circle, guys, you just can keep going around and around. So like x could be 2 pi, 3 pi, 4 pi, 5 pi. If you land on the x-axis, sine is going to be 0. All right, but I'm only dealing with this interval. So let me go to like a little number line here. And, all right, so which of these, 0 or pi, is between pi over 2 and 2 pi? All right, so pi over 2 is up here, and then 2 pi is there. So this is the part of the circle we're dealing with. So we've got pi over 2, and then we've got pi, and then we've got 2 pi. And guys, it doesn't have to look, accurate, like the distance between them. Pi could have been in the middle. We're just using the number line to figure this out. Okay, now think of the unit circle and try to pick stuff that will be like helpful. things that you know. So, so pi over 4 is nice to use. So I could do 1, 2, so 3 pi over 4 is a nice testing point, okay? And then over here, pi, oh, that's good. I could use that one. This one is actually 3 pi over 2. 3 pi over 2. Okay, so yeah, let's see what happens. So we've got sine, so the absolute value of sine of 3 pi over 4 is equal to sine of 3 pi over 4. So I just got to figure out if I need a plus or a minus in front here to get a positive outcome. All right, so sine of 3 pi over 4, sine is the y coordinate, that's radical 2 over 2 equals, that's just radical 2 over 2. So guys, you don't need the negative in order to get a positive outcome. You would only need that if you had a negative on the inside, basically. Okay, so what we just figured out is that on this interval here, the absolute value of sine is equal to sine, both positive outcomes on that interval. Okay, now let's test on this side. So the absolute value of sine of 3 pi over 2 is equal to, I'm leaving a space for the plus or the minus, sine of 3 pi over 2. Okay. All right, guys. Sine of 3 pi over 2, that 3 pi over 2 makes us land here. Sine is the y. That's a -1. Okay. So the absolute value of a negative is going to give you a positive outcome. That's 1. But without the absolute value, what would have to be in front for us to get a positive outcome? It would have to be a negative in front. So this is equal to negative. All right, so there's two ways basically to get a positive outcome. Here, you could negate a negative or you could put absolute values around it. Either way, you're getting a positive one. Okay, so on this interval, the absolute value of sine of x is equal to negative sine of x. Okay. All right, guys, I know that's like a lot of side work, but okay, that's why we're going to drop the absolute value bars and put a positive or negative. Okay, so we're going to have two integrals, one on this interval and one on that interval. So the integral from pi over 2 to pi, on that interval, you get a positive outcome regardless of whether the absolute value bars are there or not. Plus the integral from pi to 2 pi, this is the interval where you're going to get negative outcomes unless you have the bars. But you could also ensure positive outcomes by negating it, negating the negative outcomes. Okay, so now I'm ready for the fundamental theorem of calculus. As soon as you know how to take the antiderivative of what is inside, then it is time for the FTC, the fundamental theorem of calculus. Okay, so I'm doing brackets, pi over 2 and pi plus brackets, pi and 2 pi. Okay, all right, guys. Now for all right, so sine, cosine, negative cosine. All right, there's a little trick for, derivatives and antiderivatives of sine and cosine only. So for sine, or the antiderivative of sine, I'm starting here and I got to go in that direction. So negative cosine. So negative cosine of x is the antiderivative of positive sine. So for negative sine, the antiderivative, you could find it like right here. Here's negative sine. Antiderivative, you're going that way. Okay, and now final value minus initial value for both intervals. So I'm plugging in pi first. I'm going to go like this. So negative cosine of pi minus a negative. So it's minus negative cosine. So I'm going to do a plus right now, if that's okay. Cosine of pi over 2. Okay. And then this plus sign is coming down here. And then this is cosine of 2 pi minus cosine of pi. All right. And guys, you just have to know the unit circle. So cosine of pi is -1. So this is a -1. So that's a +1 plus cosine of pi over 2, that's 0, plus cosine of 2 pi, that's 1, minus cosine of pi is a -1. So 1 plus 1 plus 1 is 3. What a nice number. Okay, so there it is, guys.